Alright, this is my third video for the INTC 1291 Introduction to Test Equipment course at Brazosport College. This is the third video for the 744, or the Fluke 744. In this video I want to go through and demonstrate sourcing some of this stuff. You actually saw loop power being sourced in the last video, but I can source just milliamps for something that needs to read ampere or amperage. Okay? And again, it would be hooked up to the same ports that we hooked up our loop power to source milliamps. I can source DC voltage, and again I'm going to go to red to red, black to black, because I'm going to be using the red letters. And if you see over here, it says voltage, right? So I'm source voltage from here. And this is a good thing to say you want to test out to see what something's resistive value is. You can apply, this is going to say, I can put in up to a certain voltage, and you can see the thresholds of a resistor, apply a voltage to it, and you can measure the current going through it. If you want to do, the math for calculating the resistance of a resistor, say it doesn't have color bands on it, you can apply a voltage to it, a small voltage, and if you have a meter in there to measure your current, the voltage being applied, you can measure the current, and from there you can calculate your resistance, right? Not something we really use a whole lot. We're going to be using milliamps a lot more, RTDs, stuff like that. But going into, so that's DC voltage, right? So if I wanted to source a DC voltage, I'd hit this button, and it says I can source millivolts or volts. Right, I'm going to click the volts, and it said that my max down here is 30 volts. If I bring that up, the max voltage that I can source, hopefully you can see that, is 30 volts. And of course, go ahead and cover those maxes right now. See, the max is 30 volts and 110 milliamps, or 0.11 amps. And this is a Cat 2 at 300 volts max. That's a category rating for test equipment. And of course, I'm on the DC voltage, and I can type in, say, hey, I know I can't go above 30, right? So I can go 12. Enter. And I'm now sourcing 12 volts to something. I can go all the way up to 30. Requested source value is out of range. Of course, it says max is 30, so let's try 29.9. No, 29.9. And it says requested value is out of range. Press any key to continue. So maybe because I've got this external AC power supply and the batteries, I said our batteries died a long time ago. That's why we have these plugged in. Maybe this thing can't actually put out 30 volts right now. But with a good battery, it should put out 30. I'm going to see how high of a voltage this will actually let me put out. Nope, not 20. It'll do 9. We'll do 10. We'll do 12. 15. 16. Nope, 15. Looks like 15 is about as high as I'm going to go. Okay? 15 volts. Even though we're supposed to be able to source up to 30. Go ahead and clear that and move on to talking about if I wanted to source volts AC, I could do the same thing. I would use the same ports, volts AC, or, and this is the part that kind of is tricky. Okay, so if you wanted to source frequency or hertz, you got to realize that's associated to volts AC. So if I'm going to source frequency, I'm going to hook up to sourcing voltage. And that's the one thing they didn't label down here, or one of a couple things they didn't label, but the frequency they didn't label down here. No frequency, hertz, we're going to be sourcing voltage. What I'm actually going to do is, even though the next video is going to show you measuring everything, I'm going to show you this sourcing and then this measuring at the same time. So all I'm going to do is take this, I'm going to source the frequency, and I'm going to read the frequency by measuring voltage over here. Here it wants to know amplitude. I'm going to go 1 volt. Okay. And do I want a square wave or a sine wave? We'll call it we'll make it a sine wave. I'm going to click done, and wants to know what's the frequency. And this thing it does have a frequency range. I'm going to type in 10 hertz, which is telling you that the entire sinusoidal wave goes positive, back to neutral, negative, back to neutral. That's in one entire sine wave. And that will occur 10 times per second. That's what hertz is referring to. Now, right now I'm sourcing, right? If I go to measure, right now it's measuring, you see it's jumping all over the place because it's actually sourcing. I'm trying to measure millivolts DC. I'm going to go back to the measure screen, hit the button a second time until it goes to frequency. Now I put it in 10 hertz, right? So I got to tell it it's less than 20 hertz. It can't measure low frequency with the source on. Okay. So what we're going to do is we're going to go back to source. It turned it off. I'm going to measure. Go back to measure. Hit this button twice until we're going to go above high. So I guess that's what it's calling high. And then I'm going to go back to source. Amplitude. Sine wave. Done. And I'm going to source 25 hertz because that was above 20, right? And then I'm going to go back to measure and source, and you can see it's sourcing 25 hertz and it's measuring at the same time. So I guess that's one thing, is this can't do anything that's below. You can't source and measure anything below 20 hertz, but above it, it will measure and source at the same time. I'm just showing you the functionality. You can see that it may be, you know, just a little bit out of calibration. It's pretty. This was reading 24.99. This is 25. That's not that far off. But that's just showing you sourcing. This is actually sourcing volts AC, but in a terms of I get to pick the frequency. Okay. I'm going to go ahead and go back to source. I'm going to clear and zero that. I'm going to hit, well, go back to measure, and you saw when I sourced 0, it started measuring 0. Next thing I want to go into talking about is sourcing resistance. Okay. I'm going to take these two out, because to source resistance is I still stay over here. You see the omega symbol over here. I'm going to source, and I'm going to hit the resistance button. And he goes, "Hey, what do you want to source? How much resistance?" Now this thing, it'll go up to k ohms or kilo ohms or thousands of ohms. But I'm going to type in a standard number that should look familiar to you, 250 ohms. Hit enter. Right? And again, I can measure, right? I'm going to measure the resistance, but I'm going to measure the resistance, black for measure, and I see the ohms is here, so the middle ports. Okay? So I'm going to go, I'm sourcing and I'm measuring at the same time, but I'm still measuring frequency, right? So I want to measure, go back to just the measure screen, hit the ohm button, and what do you know? It starts measuring. I can read, measure, and source at the same time. I'm sourcing 250 ohms. It's measuring 250. That looks pretty calibrated to me. Now, when it comes to the next function, which is the thermocouple RTD, I'm going to go ahead and start out talking about the RTD. I'm going to go back to measure, and I'm going to change this to measure. Hit this button, and I get to pick between thermocouple or RTD. I'm going to click RTD. And I had to tell it what kind of RTD it is. I have a menu here, you know, Platinum 100, 3926, platinum 100, 385, which is the most common. We have nickel, platinum 200, platinum 500, platinum 1000, copper 10, platinum 100. And I'm going to go back to the platinum 100, 385. And I can do 2-wire, 3-wire, or 4-wire measuring, right? I'm going to measure just a 2-wire. And it even shows you how to hook it up, right? So you got your 3 ports. So it's hooking up where I would measure resistance. Even though this is labeled as this is RTD2, measure RTD, right? If I wanted to do a 3-wire, it's going to show me where to hook it up. And really, I'm just going here, and I'm going to hook my 3rd wire into this port. Even though it's not labeled for RTD, this screen is going to tell you you're going to plug your 3rd wire in here. And if I want to do a 4-wire RTD, I'm going to plug the 4th wire, and you can see basically the 2 wires of the same color go up here, and the other 2 wires of the same color go down here. And RTD is red and white. I stick my 2 red wires plugging into here. My 2 white wires would be connected to these 2 ports. Does not matter. You can go 2 white, 2 red here. A resistor is a resistor. Polarity does not matter. But this will at least show you. The manual will also show you how to hook it up, but at least on screen they give it to you. I'm just going to do a sourcing 2-wire right now because that's what I've got. And you notice it goes straight to picking the temperature for a platinum 100, 385. Right, I'm going to take these out. So I'm measuring right now, right? I'm trying to measure an RTD. Now what I'm going to do is I'm going to go back to source, and I'm sourcing resistance right now, right? And I'm sourcing 250 ohms. So if I plug this back in and I go back to measure, it's telling me that 250 ohms for a platinum 100, 385 RTD, that much change or that much resistance added on top of the base 100 should mean that the temperature, if I had an actual RTD hooked up to something, was 767.1 degrees Fahrenheit. But I'm sourcing resistance. I can change that source to actually source RTD, and I'm going to source a platinum 100, 385, and now I get to pick the temperature. Right, so say I want to say 100 degrees. Now when I go back to measure, it'll read 100 degrees. But what it's actually doing is putting resistance on the line. If you look carefully, bring this closer to the camera, you can see that it's sourcing 114.682 ohms. And of course, when it measures, it's rounding it. It's not giving you 3 digits, but it's rounding this up to 114.8 or 114.7 ohms. Okay. So this is actually showing you sourcing and measuring for an RTD. Go ahead and clear. Come in here, measure, source, hit clear. I'm going to stop sourcing RTD. And I want to show you sourcing a thermocouple. All right. Which the thermocouple is down here. If you actually look, it's kind of etched into the casing. It says TC for thermocouple. And again, we have a smaller and larger slot for this because thermocouple wires are polarity sensitive. The red wire is always the negative wire. The other color wire is going to be your positive. And of course, the color of this wire is how I determine what type of thermocouple this is. And, you know, leave something in the comments if you know what kind of thermocouple this is. Hint, it's probably going to be covered later. Or this video is probably going to give you the answer. All right, so I got my thermocouple plugged in. Oh, I lost power. Turn it back on. Keep touching that. All right, so I'm going to source a thermocouple. So I hit the TC RTD button. I'm going to pick thermocouple. And this is where I got to tell this meter what I want to source. Now this is the answer to that previous question. And of course, if you look, it's also labeled K. Okay? So yellow is K. It's a K-type thermocouple. So I come down here. The options are E, N, J, K, T, B, R, S, C, L, U, B, P, X, K. It's got several options. But I'm going to go to the K. And I'm going to go to linear millivolts. Right? Actually, abort. I'm going to go to linear temperature. I'm going to source that again. I'm going to hit the thermocouple button. Go to thermocouple, K, and linear T is saying linear temperature. So I'm going to hit there. So now I got to punch in the temperature that I want to simulate. So how would we actually use this is instead of having an actual thermocouple hooked up to, say, a temperature transmitter, I would use this thermocouple extension, and this Fluke 744 would be acting like it was the actual thermocouple, and it'll produce a millivoltage just like thermocouples do, to make the transmitter see a change in millivoltage, and then we can use that to calibrate the sensor trim or do a sensor trim on the transmitter to make sure that the millivoltage it's seeing, it's corresponding that to the correct temperature, and then we can also do an output trim to make sure it translates that to the appropriate milliamps. Right? And this allows us to do it in the shop where we don't have to have something, say my thermocouple is supposed to be reading something up to like 800 degrees Celsius, I don't have to have something that's 800 degrees Celsius to test or to calibrate my transmitter. I can do this in the shop with something that's going to produce the millivoltage that a thermocouple would produce when it's at 800 degrees Celsius. I don't have a temperature transmitter handy right now. Don't have it hooked up, but just showing you where it plugs in. And I can type in, say I wanted to produce 240 degrees Fahrenheit on a type K. I could take this, and remember the red wire is negative and the positive is yellow, and I could actually go and measure millivolts. Now I have this plugged in, and normally I would want to make this nice and pretty, give it something to connect on, but I'm just going to stick it into my negative and my positive. Make sure it's making good contact. And I'm not seeing, it's saying it's putting out 3.781 millivolts DC, but I'm not seeing it on the measure. And it may be because I'm just not getting a good contact. But if I were to hook this up to an actual temperature transmitter, it should see the millivoltage coming in from a standard thermocouple and convert that to, interpret it as a temperature. And the beauty of this is when I'm in the source, I type in the exact temperature here, and then when I'm connected to the transmitter, I should be able to get a reading from that saying, hey, I see this as 240 degrees Fahrenheit, as long as the transmitter is set up as the same type of thermocouple. Right. Next thing I do want to cover, which is going to be the pressure. Which unfortunately, during this COVID-19 episode, they have shut down a lot of the functions of the campus. which unfortunately means they've turned off my air compressors, so I don't have any actual air pressure to hook up to show you at the moment. But I will at least show you how you connect things to do pressure with this, right? Again, you need an external pressure sensor. This happens to be the Fluke 750 P05, 30 psi range, or 200 kilopascals, or 2 bar. Right? And again, with this external pressure sensor, you're looking for the red dot on the sleeve, and there's a red dot at the top of this port. There's 5 pins. It does not twist, it just plugs in, and it won't come out unless I reach in here and pull the sleeve to disengage it. Now I'm going to hit the pressure. It's attempting to a connection to see if there's something connected. There is. It's connecting to this, and right away I've connected it, and I'm not hooked up to anything. I have no, I mean, if I tap this, you'll see the pressure goes up, right? But if I leave it alone, whatever it goes to, this is referencing whatever the pressure in the room is, which we will treat that as, you know, atmospheric pressure. I want to hit my clear 0 button, and it's going to zero out this pressure sensor. So it's saying, hey, whatever you're seeing right now with nothing hooked up is 0. Now if I hooked up, this is an H9 conversion here. I can take an H9 hose, hook this up to my hand regulator, and actually crank that up and start seeing it in inches of water, right? Remember how I can change the units is by going into setup, hit next page, and here's my pressure units. Hit enter. I'm going to go to PSI in this case. I'm going to hit done, and as soon as I come back out, of course I'm on source right now, but I want to measure pressure. Now, Fluke said you can measure, technically hit pressure and measure and or source at the same time, but really it's just measuring, and you're controlling the pressure that this sensor is measuring with an external regulator, whether it's the Fluke device or a hand regulator. Cannot simultaneously measure and source pressure. Okay. But measure, and here it's reading 0.005. Again, I'm going to hit 0. Okay. And if I just put my thumb on there, increases the pressure in there slightly. Taking it off. And so I really wish my compressors were working so I can show you it going up and down, but this is the function of using this to measure or source, as Fluke likes to say. We're just going to stick to measuring. So that should cover most of the functions here. We covered sourcing current, voltage, volts DC, volts AC, frequency, resistance, thermocouple, RTD, and pressure. Okay. Next video, I'm going to be showing you how this goes into actually functioning as a communicator of some sorts. I'm going to hook right back up to that 3051. So make sure you check that video out.